9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Electron has successfully lifted off from Rocket
Stage
Lab
one
Launch
propulsion
Complex
is
1 with its Spire and North Star payload. The rocket is on its way to low Earth orbit with those 4 satellites on board, now T plus 40 seconds into flight. Electron has begun its pitch over, moving up and on an angle to head away from the launch pad and out over the ocean. Now all is looking nominal so far as the rocket approaches max Q, the moment in ascent when Electron experiences the maximum amount of aerodynamic pressure.
Electron is supersonic, approaching max Q. Cleared max Q.
A good call out from Mission Control there that Electron has cleared max Q. The rocket is now 16 kilometers in altitude and moving at over 2,000 kilometers an hour, which you can track the mission's progress by that telemetry dials at the top right-hand corner of your screen.
Next up for Electron is MECO, or main engine cutoff, quickly followed by stage separation and the startup of the Rutherford engine on that second stage to continue the mission to orbit. The 9 engines of the first stage will throttle down and then shut off just before the first and second stages separate from each other. When that happens, the second stage with the Spire satellites will maintain its orbital trajectory and continue on with the mission, while the first stage of Electron will begin its reorientation maneuver to position itself for the return journey to Earth. Now, these 4 events happen in quick succession and are coming up shortly.
15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
That's confirmation of MECO, stage step, and Rutherford engine ignition on stage 2. The telemetry dials at the top of your screen continue to show the speed and altitude of the second stage for the primary mission, with the stage 2 nozzle glowing bright above the stunning Earth.
Stage 2 propulsion nominal.
Fairing jettison succeeded.
That was the call for fairing jettison on the second stage, which you saw there for yourself. That means Electron's nose cone has successfully split apart and fallen away. And we do this in preparation for deploying the kick stage with its satellites and to get rid of the dead weight of the fairing now that we are through Earth's atmosphere. We have got the trajectory graph showing on your left-hand side and on the right-hand side, which track the stage's current altitude, matching the nominal altitude that we need to reach orbit. On the left-hand side, Electron's stage 1 trajectory is on its way to the highest point of its momentum arc, and once it reaches this apogee, the stage's trajectory line should start to come down as its altitude begins to drop too. You are seeing, though, on your screen that movement of the booster as it redirects to come back to Earth bottom heavy. That way, the engines bear the brunt of the re-entry forces rather than shredding the carbon composite at the top of the stage. The stage will move quickly as it is pulled back to Earth by gravity, and at its peak, the first stage will reach around 8 times the speed of sound and generate so much friction that we could see a red-orange glow from the heat as it descends. It is T plus 4 minutes and 33 seconds into the mission, and Electron's second stage carrying today's payloads remains on course for payload deployment within the hour. Now that second stage is clocking speeds at more than 10,000 kilometers an hour, having now passed 174 kilometers in altitude. For Electron's first stage on its return journey back to Earth, we have had the stage reach its apogee, flip into its atmosphere re-entry position, and begin dropping in altitude as it speeds up on its homeward bound trajectory. It will travel this way for a few minutes before its drogue and main parachutes are deployed to help slow it down.
The end of Stage 2 may look a little different than what you're used to from our previous launches, but this is due to the implementation of BEAST, or our electrical arc suppression system, which ensures all electronics on board can function nominally. In particular, you might notice the addition of a nitrogen tank that maintains pressure within this stage. We're now listening to hear the call from Mission Control for battery hot swap. This hot swap maneuver will allow the continuous energy supply to the Rutherford engine's electric pumps, which deliver fuel to the engine's combustion chamber at extremely high pressure.
Hot swap successful.
A good call from Mission Control. Electron's second stage has completed the battery hot swap. The second stage is maintaining its momentum at more than 15,000 kilometers an hour, now past 200 kilometers in altitude.
And we are currently at T plus 6 minutes, 39 seconds into the mission, and the next critical milestone we are tracking is the deployment of the drogue chute on Electron's first stage. Watch that left-hand side of your screen.
AFDS has saved. Confirm drogue deploy.
As you can see on your screen there, a fantastic view that we have the drogue parachute. It has been deployed from that first stage of Electron. We heard that call from Mission Control as well, so that seems like a nominal drogue chute deploy since we haven't heard anything different from our operators. That means we'll move next to the main parachute deploy, coming up in around 30 seconds, which we should also hopefully see happen from that live camera feed on stage 1.
Main parachute deploy. HVB battery discharge, holding nominal.
Another great call out from Mission Control. The main parachute on Electron's first stage has successfully deployed. This means the booster's pace will have slowed down significantly and should now be drifting gently towards the ocean. It's expected to take around 10 minutes for the booster to reach the water surface, but we'll keep the comms channels up from Mission Control to share updates as they come through.
Entered burnout detect mode.
Guidance is in terminal, 26 seconds remaining.
Now back to the primary mission, and we are coming up on the final few seconds of stage 2 engine burn. We will then have second engine cutoff, or SECO, which shuts down the engine ahead of the kick stage separating for its phasing orbit of Earth. And we're listening out for those events now.
SECO confirmed.
Stage 3 separation confirmed.
great news from Mission Control with that second stage engine cold and the kick stage separated. We are now in the final stages of this four-of-a-kind mission. The kick stage and Spire and North Star satellites are now in a coast phase around Earth. After that elliptical orbit of Earth is complete, then the kick stage's engine will light up to set the stage and the satellites on a circular orbit before payload deployment. The stage's coast phase will last about 40 minutes or so, and then there is payload deployment before we can call mission success for Electron's 43rd launch.
Before we break, though, the latest on recovery is that all is continuing as planned for Electron's first stage and its slow descent to the ocean. Our recovery crew are on standby in the recovery zone, waiting for that splashdown before they can move in and get to work.
Take a bit of a break now on the webcast, but we will come back to you in a few minutes with confirmation of that booster splashdown when we hear it. So we'll leave the audio channels up so we can listen in for that in real time from Mission Control. Otherwise, we will see you back here shortly.